All right. Hello.
Hello.
All right. Good try. Good try. All right. Okay. For all those people pretending like they're at home with strep, good job. Thank you. Now let's take a look at. We did A, didn't we? Yes. Okay. So let's start with B. So start by plugging it in to see what we get. So when we plug in this, slightly off, it'll work. When we plug it in, so it's going to be infinity over e to the infinity. Yeah, there we go. So that's going to come out. So e to the infinity just gives me infinity. It goes up to infinity, right? Yeah. And infinity, still infinity, right? Yeah. So it's going to be infinity over infinity, because e to the infinity is infinity. So in the end, it's just going to be same thing. Infinity over infinity. Now, let's go ahead and do the derivative. So the derivative of the top is 1, right? So it's 1 over the derivative of the bottom, e to the x, or e to the infinity in this case. So now, e to the infinity. So if I take this number 1 and I divide it up by one piece, that's going to be 1, right? Okay, what about 2 pieces? So I'm making this number bigger. I'm making the bottom number bigger. So if this becomes 2 on the bottom, so I get 1/2, right? What if I make that 1/4? 1/4. What about 1/10? Okay, 1/100. Even smaller, right? So as the bottom of this gets smaller, as it goes to infinity, what does this eventually go to? 0. This right here is going to go to 0. So 1 over infinity is always going to be 0. All right, so the other one. So on C, that's going to be e to the infinity over infinity. Infinity over infinity, right? Now, derivative of the top is going to be e to the x, or in this case, e to the infinity, right? Over derivative of x is just 1. What do you think I'm going to get there? Infinity, right? E to the infinity. What does that go to? It goes up to infinity, right? As those numbers keep getting bigger, this thing just keeps going up to infinity. All right, so here's a property right here, ln x over x to the n, where any value, right? Okay, it's going to give me 0. And then x to the n over e to the x is also going to give me 0. So these are good things to know. It's almost like I gave you guys flashcards that might have this on there. Oh, I know, right? Okay, but no one touched those flashcards, but good job. All right. Okay, L'Hopital. So first, let's see, what is tangent at 0? So tangent, unit circle, I'm thinking about it, sine over cosine. So at 0, it's all the way to the right. So that means that the y value is 0 and the x value is 1. So that's going to be 0 minus, what is sine at 0? 0. Over x squared is going to be 0 squared times 0 again. So I get 0 over 0. So now that I have 0 over 0, that is the indeterminate. And I could go ahead and start by taking the derivative. Derivative of tangent is? Secant squared x. Derivative of negative sine? Negative cosine x over, that's going to be a product rule, which would be a 2x tangent x plus x squared and secant squared x.
Wouldn't it
Positive cosine. Negative sign. So think about negative sign. So on my,
It was already minus.
yeah,
So
it's already a minus sign. So let's see, I have a cosine, sine, negative sign, and negative cosine. All right, so as I do the derivative, sine goes to cosine, right? And cosine goes to negative sine. So I had negative sine goes to negative cosine.
but it was already a minus sign.
Negative sine.
No. Wait.
I'm just thinking of it like this, the whole thing in all together. So even if I disregarded the negative, if I disregard the negative and just say, what's the derivative of sine? Cosine. Okay, there's a negative in front of it. Yes? Okay, good. All right. Okay, so I think we're right about here. So secant at 0. Let me see. That's reciprocal of cosine. Cosine at 0 is 1. So 1 over 1 squared is 1. Minus, again, cosine at 0 is 1 over, let me see. This is going to give me 2 times 0, which is 0. And this is going to give me, again, plus 0. So that's going to give me 0 over 0. All right? So there's the first derivative. Let's do another derivative. Yay! All right, so let me change colors on this one. Let's do that. Maybe that. No, I said change colors.
Light blue.
Nah, no, doesn't work well here. There we go. All right. Okay, so derivative of secant. What's the derivative of secant?
Secant tangent.
And this is going to be derivative of negative cosine. Positive sine, right? Okay. Bottom's going to look kind of ugly because I got two products, right? Okay, so that's going to be a 2 tan x plus 2x and secant squared x, okay, plus 2x secant squared x plus x squared, and derivative of secant is secant tangent. All right, okay. Kind of sucks if I'm using blue and I'm trying not to write on the blue. It's a horrible thing. Anyway. Okay, so it's ugly, isn't it? Yeah, okay. But now we're still plugging in 0, so that's always a fun thing. So let's see. Tangent at 0 is? 0. So all this, because there's a 0 right there, that becomes a 0. 0. Okay, that's going to be a 0 there. And secant, that's a 0 there. There's a x there, so that's a 0 there. And that is a 0 over there. Isn't this one fun? No. So what are we left with? We got 0 over 0 again, right?
Yes.
Okay. So let's go ahead and clean this up. This is bugging me. All right, I gotta correct it. so that's restarting. Okay, so we had 0 over 0. Let's go through and do some manipulation because I don't like all this work. I really don't. Okay, so we can combine a lot of this crap, can't we? I hope so. So it's going to be, let's see, that's better. So I'm going to have a 2 secant squared tangent x plus sine x over, let's see, they all have a 2 at least. That doesn't help. All right, 2x secant x. So how about these? I could put those together, and yeah, I could put those two right there together. So that's going to be a 4 secant squared. So it's going to be a 4x secant squared x plus 2 tangent, right? X, and then plus 2x squared secant squared tangent. There we go. All right. Ugh. This is getting super ugly. It's going to get uglier, isn't it? So it's time to actually go back and see if we could do some of those, like, identities. All right, so I'm going to, you guys have probably never seen this before because I invented this math. So, 2 secant, so now this math is based on the premise of certain things. That in an ordered pair we have an x comma y, right? And if I'm looking on a unit circle, it's going to be the cosine, right, comma sine, right? Yep. Okay. So if I use my identities, I can replace everything with x and y and treat it like an algebra problem. Okay? So, and in this case right here, I'm going to say that x, which is one of my variables, I'm going to call that 1 theta. Because I don't want to mess it up. And it's going to make the trig identity so much easier. All the trig identities turns into algebra. You can manipulate algebra. So if I start off with my problem, which is 2 secant squared, right? Actually, let's go back to the top and start from there. So tangent is sine over cosine, isn't it? Okay, so sine over cosine, so that's going to be y over x. And minus sine, which is over 1, right? Over. And then the bottom is going to be x squared. So I'm going to call that my theta squared times tangent, which was y over x. So we're going to manipulate this to try and get rid of a lot of this stuff. So by doing this, it's going to make life a whole lot easier. What's my common denominator of the whole thing? There's only one denominator. Say x. X is my only denominator. So, because x, 1, 1, x. So I only have x. I'm going to multiply everything, top and bottom, by x over x. This is algebra here. So as I distribute, the x's will cancel. I'm left with, say y. Y minus x y. Because nothing canceled here, right? Okay? So all this together, because all this is multiplied together on the bottom, when I multiply it, the x is going to cancel, right? If the x's cancel, I'm going to be left with y, and then I'm going to be left with theta squared. Hmm?
Sorry, it looks like yo.
Yo. Okay. Now, does anyone see how this became super easy now? I could take a y out of everything, right? So I'm technically factoring out a sign out of everything, right? I'm factoring out a sign from everything. So if I factor that out, it's going to be y parentheses 1 minus x over y then theta squared. Now what can I do with that y over y? I can cancel that. Now, let's rewrite it in trigonomic form. This was algebra form, so we could do all the manipulation that we need. But I bet you guys didn't see that we could have factored out a sign out of everything from just looking at the original problem. Right? It's not that easy to see, so that's why I wanted you guys to see it like this. So I'm canceling those out, and I'm left with, okay, on top it's going to be 1 minus cosine x, right, over x squared, right? You notice right here my x was just the theta, right? That was my variable theta. Now let's go through and do my derivative now. Because if I plug in 0, I'm still going to get 1 minus 1, right? I'm still going to get 1 minus 1 over 0 squared. So 0 over 0 still happens here. It's the same thing for this is going to happen. But now let's take the derivative. So the derivative is going to give me derivative of cosine, or I'm sorry, negative cosine? Positive sine, right? Positive sine. So it's going to be a sine over 2x, right? So the derivative of the top over the derivative of the bottom. So look, now what is sine at 0? 0. And as I plug in 0 here, I get 0 over 0 again. The same thing what I got before, but I had a big nasty problem, didn't I? Simplify before I actually do all this. All right, so now let's do a derivative one more time. Derivative of sine? Cosine. So it's cosine of x. Derivative of 2x? 2. So now as I plug in 0, what is cosine at 0? 1 over 2. Better? No? Maybe? I thought it was a good problem. Because you could see the difference of, you know what, just trugging along without any trig identities, or use a trig identity and it makes it a whole lot quicker. A whole lot easier. Anything you see, sine, cosine, tangent, you can reduce it possibly, if you can, and then do your math. All right, I'm going to leave off on that. So don't forget, like, share, and subscribe. Hit that notification button.